Hello everyone and welcome to Bell Explains. In this video, I will be doing 1.1 Index Notations. Let's get to it. Complete the following table with base or index for the given numbers or algebraic terms. So here we have 5 to the power of 3. As we know, the formula for an algebraic term is a to the power of n, which means a is the base and n is the index. So here we know that 5 is the base and 3 is the index. So here we'll put 3. So here we have index 7. Here, the only number that has an index of 7 is negative 4. So the base will be negative 4. And next, base 1 over 2. So here we have base 1 over 2, which means the power is 10. Here we have index 6, which means the base will be m. For n, we have 0. For 9, we have a base of 0.2. For an index of 4, we have negative 3 over 7. For a base of x, we have 20. For index 2, we have 2, 1 over 3. And for base 8, we have, here since there is no power, which means it is a power of 1. So here we'll have index 1. Next, state the following repeated multiplications in index form a to the power of n. So as we know, index is the number of repetition. So here we have a multiplication of 6. So let's count the number of repetition. Here we have 1, 2, 3, 4, 5, 6, which means the index is 6. So here we have index 6. And the base will be the number here, this number. So we have base 6 and index 6. So a to the power of n will give us 6 to the power of 6. Next, for b, we have a multiplication of 0.5 7 times. 1, 2, 3, 4, 5, 6, 7, which means the index is 7. So here we have base 0.5, index is 7. So we have a to the power of n is 0.5 to the power of 7. Next, for c, we have 1 over 2, multiplication of 4 times. So 1, 2, 3, 4. That will give us base 1 over 2 and index 4, which means a to the power of n will be 1 over 2 to the power of 4. For d, we have base negative m, this number, this term is negative m, so we have negative m for base, and index will be 5 times because 1, 2, 3, 4, 5 times. So a to the power of n will be negative m to the power of 5. Next, for e, we have 1, 2 over 3 for the base, and index 3 times because it's a multiplication of 3 times. For f, we have 1, 2, 3, 4, 5, 6. So we have index is 6, base negative 1 over n, which means a to the power of n is negative 1 over n to the power of 6. Convert the numbers or algebraic terms in index form into repeated multiplications. So here we have negative 3 to the power of 3, which means this index is 3. We have to times it 3 times. So we have negative 3 as the base times 1, 2, and 3. So 1, 2, 3. Next, for b, we have 2.5 to the power of 4. So we'll have to times it 4 times. 1, 2, 3, 4. For c, we have 5, index of 5, which means we'll have to times it 5 times. And that is how you do it for the rest. Next, write each of the following numbers in index form using the stated base in brackets. So here we have 81 to the base of 3. So this is how we do it. We'll put 81 here, then we divide it by 3. So that will give us 27. So we divide it by 3 again. That will give us 9. Divide by 3 again, we get 3. And divide by 3 again, that will give us 1. So repeated division, we have to do it until we get 1 at the end. We know 3 is divided 4 times, which means the power is 4 times. So here we have the base is 3 and the index is 4. So we know that 81 is 3 to the power of 4. Next for B, we have 15625 base of 5. So by putting this into your calculator, we know that 15625 divided by 5 gives us 3125. Divide by 5 again. That will give us 625. Divide again gives us 125. Then you divide again until you get 1. So you'll keep dividing. So here we have 1, 2, 3, 4, 5, 6 times. So here we know the base is 5. The repetition is 6. So 15625 is 5 to the power of 6. Next for C, we have 64 over 125 to the base of 4 over 5. So here, since the base is 4 over 5, we'll put the numerator as 4 here. That will give us 16. Divide by 4 again, we get 4. Divide by 4 again, we get 1. So here the repetition is 3, which means the base is 4 and the index is 3. For this number, we have the denominator is 5, which means we divide by 5. That will give us 25, then 5 again, and then we get 1. So we have the base at 5 and the index at 3 because this is repeated 3 times. So since the index is the same, we have a function of 64 over 125. That will give us 4 over 5, since this is the base, and in the index we'll have 3. For D, we have 0.00032 divide by 0.2. So put it in your calculator and that will give us 0.0016 divide by 0.2. So that will give us 0.008. Divide again by 0.2 and that will give us 0.04. Again by 0.2 and that will give us 0.2. So again, and that will give us 1. So here we have a repetition of 5 times, which means the base is 0.2 and the index is 5. So here we have 0.00032 equals to 0.2 to the power of 5. For E, we have negative 16384 divided by negative 4. Since it is negative and negative, we'll get a positive number here of 4096. Divide by negative 4 again. So since positive and negative, it will give us negative 1024. And divide by negative 4 again. Since it's negative and negative, we'll get a positive number here. Divide by negative 4, we'll get negative 64. and that will give us 1. So here we have a repetition of 1, 2, 3, 4, 5, 6, 7 times. So we have the base at -4, index which is at 7. So we know that -16384 gives us -4 to the power of 7. And lastly for f, we have 1/16 with the base of -1/4. So since the numerator is the same, we'll take the denominator and do the repeated division. So here we have -4. That will give us negative positive, will give us -4, and here it will give us 1. So here we have a repetition of 2, which means the base is -4 and the index is 2. So since this was only done for the denominator, we have 1/16 is 1 over base is -4, and that will give us a square here. Calculate the value of each of the following numbers in index form. So here we have 9 to the power of 4. Just put it in your calculator and that will give us 6561. Next for B, we have -4 to the power of 5. So when you put this in your calculator, make sure to put the bracket first, then -4, close the bracket, then put the power of 5. So that will give us -1024. For C, put it in your calculator as bracket 2.5 to the power of 3. So that will give us 15.625. Next for D, bracket -3.2 to the power of 3. So that will give us -32.768. Next for E, we have bracket 3/8 to the power of 5. So that should give us 243/32768. Bracket -1/6 to the power of 4, and that will give us 1/1296. For G, we have 2/3 to the power of 2. So that will give us 25/9. And lastly, for H, we have -2, 1/3 to the power of 3. So that will give us -343/27.